We'll proceed in vector and commercial calculus. Vector and commercial calculus discussion that we are pursuing, and we are in a phase of flux density, divergence, and then we can calculate flux density from the flux. Okay, we can calculate divergence from the velocity vector, and indeed both are same. Flux density and divergence both are same. The way we saw in curling, we took a topic of curl, that is line integral. In line integral kind of sense, then if we go for kind of circulation density, if I calculate line integral, the force vector dot product with the line vector, that is energy. Force vector dot product with the line vector, that is energy. Force vector dot product with the line vector. And if it is in a closed loop, divide it by the area. This is also called circulation density, and it is equivalent to curling factor. If the force vector is F vector, that is F1i plus F2j, dF2 by dx minus dF1 by dy is called curl factor. The curl factor is same as circulation density. Circulation density means if there is a vector field of force field dot product with the line vector or d of position vector, and if it is for a closed loop, divide it by the area, that is circulation, that is density, and that is same as the curling factor. Now if I talking about flux, flux means if there is a liquid that is passing through the surface, then how much is the liquid in volume coming out of it? There is a liquid which I know the velocity of the liquid, and it is passing through a surface, then how much volume cube per second, how much the volume of the liquid that is coming out of it per second, meter cube per second. This is also called flux. Okay, if I have a closed surface, okay, if I have a closed surface, if I have a closed, the surface is closed. This is one side of surface. I believe many times I have demonstrated this. So this is one side of the surface. Okay, if this is a cylinder, oh, if this is a cylinder, then this is one side of the surface. This is circular. This is another side of the surface. Okay, so this is one side. This is another side. This is third side. I'm talking about one side. From one side, if liquid is passing, how much liquid will pass through? But if I take a closed surface, this is closed surface. All around it is closed. This is a closed surface. If liquid is passing to a closed surface, then how much is the liquid that come out of the surface? Up, 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 up. Okay, what do you mean by closed surface? This is open surface. I mean, how I can show. This is the open surface. Okay, if if kind of if one side of it, okay, one side of it, that is a circular. If I take this out, the circular part, if I take it out, it is a flat surface. So this is not a closed surface. Okay, because this one side of this cylinder is an open surface. This is open surface. This is open surface. But if I stick all together, it becomes a closed surface. But this closed surface has three distinguished surfaces. Okay, three distinguished surface. Something, if I make like this is an open surface. One surface, two surface, three surface, four surface, five surface, six surface. Now, if I add all this, it becomes a cuboid. That is a closed surface. This is a closed surface. It has one surface only. Full is one surface, but the way it is assembled, it looks like a closed surface. If there is a velocity, if there is a liquid that is passing and hitting it, then coming out, how much is the flux that is coming out of this surface? Okay, If liquid is entering, then it is also called flux. But flux is negative direction. If something is entering, this is a flat surface. There is no entering or exiting, there is only exiting. So if liquid is coming, then liquid is exiting from here, no entering or exiting. This is a flat surface. But if I make a cuboid, or this this a cylinder, then from here liquid is entering, from here liquid is exiting. If liquid is exactly, if this is x axis, this is y axis, this is z axis, then if this is oriented along x axis and liquid is entering from the x axis, coming out from here, from this side, this surface has perpendicular vector, this surface has perpendicular vector like this. This this is YZ plane and liquid is going in X direction. X axis is always perpendicular to the YZ plane. No liquid will come out from here. Okay, so the question arising is, if I know the velocity vector is along X axis. If I know velocity vector, I know area vector. Then how much is the net flux coming out of it? How much is the volume of the liquid that is coming out of it? Velocity vector dot product with the area vector. Dot product, because velocity can be along the area. Area vector is perpendicular to the area. If this is the area, area vector is perpendicular to the area. If this is area, every point area vector is perpendicular to the area. If this is area, then every point area vector is perpendicular to area, and this is in minus x direction. Here this is in x direction. Here it is in yz plane somewhere. Okay, so if velocity vector is along x-axis, maximum throughput will be received. If velocity is along y-axis, then flux will be seen along this surface, not on along this surface. Velocity vector dot product with the area vector, velocity vector dot product with the area vector is the net flux that is coming out of it. Now this much we have seen. If velocity vector makes angle, if velocity makes angle, less throughput will be seen because there is an angle now, cos theta, that will come. Velocity vector dot product with the area vector. There is something called divergence. Divergence means this velocity vector, if velocity vector, liquid is passing this surface and liquid is coming out of from here, if this entering velocity and exiting velocity is same, then the flux is velocity vector dot product with the area vector. If this is velocity vector, then area vector is along minus x axis. Net flux is negative. Net flux is negative because liquid is entering here. Actual the flux is how much it is coming out of the surface, but here it is entering the surface. So flux will be negative, but here it is coming out of the surface. Something like God has given a liquid source inside it, and liquid is coming like this out. So this one making believe like this, okay, but this one liquid is entering from here. So here it is called flux. If velocity that is entering here and velocity that is exiting here, it is same, and area is also same, the net flux will be zero. Net flux will be zero. Net divergence, net flux is zero because this side flux is negative, this side flux is positive. Then otherwise, if velocity with it is entering here and velocity with it is exiting here, if they are different, then it proves that there is a extra liquid source inside this that is making the velocity grow, increase. Otherwise, how velocity will increase? Velocity entering here is x and velocity exiting here is x plus 10. Means inside this there is a liquid source, and liquid source is adding more liquid. Because of that, velocity is growing, and with more velocity it is coming out. If area is same, net flux is more, net volume that liquid is coming out is more because liquid is getting added. This, someone would say, to me looks like the velocity is changing. He's not saying there is some source kept inside this. Velocity of the liquid is changing when it is entering here to it is exiting here. All the way it is growing. Time to time it is growing. If liquid has a velocity vector f, and that is f1i plus f2j plus f3k, then x-axis component is called f1 Y-axis component is called F2 and Z-axis component is called F3. The velocity vector F vector, capital F on top of it arrow mark, F vector equal to F1I, F1I vector plus F2J vector plus F3K vector. If F1 entering and F1 exiting is different, then dF1 by dx is there. The F1 is changing along x-axis. If F2 is changing, F2 is changing along y-axis. If F3 is changing, F3 is changing along z-axis. How much is the net change we are seeing? dF1 by dx plus dF2 by dy plus dF3 by dz. That is the net change we are seeing. If this change, if I say dF1 by dx, the velocity along x-axis, how much it is changing along x-axis? Okay, if it is changing, then it is making someone believe that there is energy source that is inside it and that is emanating liquid. That's why velocity is growing. Or if it is not throwing a liquid, then it is sucking the liquid. That's why velocity is decreasing. But change in velocity is seen. That is called divergence. Divergence means divergence at a point. There is a point inside this. At that point, liquid is gushing out. Or at that point, liquid is coming inside. If liquid is coming inside, then input velocity will be more and output velocity will be less. If there is some hole out there on the path of x-axis at the origin typically, or if at the origin there is a point from which liquid is gushing out, then this velocity is less and this velocity will be more. Whatever, if liquid is gushing out from the origin, this is centered at the origin. This is x-axis, this is minus x-axis, this is plus y-axis, this is minus y-axis, this is plus z-axis, this is minus z-axis. Center of this is the origin. dF1 by dx is positive, means at the origin liquid is gushing out. If dF1 by dx is negative, liquid is getting sinked. One hole is there. If dF1 by dx is negative, means the liquid is coming from this side and it is vanishing at the origin. Liquid is coming from this side, it is vanishing at the origin. That's it called minus xi. Now consider there is a velocity of the liquid, and that is minus xi plus y by minus xi plus y by 2j plus z by 2k. In that sense, minus x means from x-axis liquid is going towards origin. Minus x from negative x-axis liquid is again going towards origin. At the origin, there is liquid coming from this. Plus y by 2j. From origin, liquid is going towards y-axis. Plus z by 2k, liquid is going towards z-axis. Okay, outward, in y-axis outward, minus x coming inward. But the essence is same. Minus x is, if I consider as 1, minus 1, then y by 2, z by 2. Whatever liquid is coming to the origin, same half of it is going in y direction, half of it is going in z direction. This is called net divergence at the origin. Net divergence of origin is 0. At the origin, actually, though there is no liquid source at all, neither hole is there. Whatever liquid is coming from x-axis, same liquid is going out. Divergence formula, how much at a point, how much liquid is gushing out, or that is positive divergence. Negative divergence, how much is the liquid coming to the hole at that point. That is dF1 by dx plus dF2 by dy plus dF3 by dz. Okay, that is same as something called flux density. We talked about circulation density in 2D, and that is the curling factor. In flux also there is called flux density. Flux density means if I know flux of this closed surface, flux of this closed surface that is required. This is a closed surface. This is open surface. This is closed, full is closed surface. Now, if there is a liquid source is there and it is passing through this, then how much is the net flux coming out of it? Net flux coming out of it. From this side it is entering, this side is exiting. How much is the net flux coming out of the surface divided by the volume gives the flux density. It is same as the divergence, dF1 by dx plus dF2 by dy plus dF3 by dz. Now fundamental is, if I calculate the flux density from the flux, I am calculating flux density from the flux. That is That is, you know the flux, divide it by the volume or calculate the divergence. Okay, divergence is not dependent upon the surface or volume, only on the velocity vector. Anyway, but if I have flux density, from that we can calculate flux. Please watch 3 4 videos prior or something like that. If I have flux density, from flux density I can calculate the net flux. Okay, that is flux density. Flux density, that is divergence also, that is an algebraic equation, not a vector. Df1 by dx plus df2 by dy plus df3 by dz. What is the flux density? What is divergence? If I say the velocity vector is x, y, z, x into y into z, df1 by dx, that is yz, plus xz plus xy. This is the net divergence, yz plus xz plus y xy, df1 by dx plus z. All is full is algebra. Whatever the flux density I am getting, if I am get that is through divergence I calculated, but same thing someone can calculate the net flux coming out of it, divide it by the volume. Okay, net flux coming out of it, divide it by the volume, whatever it is. If I have the flux density, if I divide it by the volume, then for flux density or divergence is calculated at a particular point. There is no meter cube. Flux is meter cube per second divided by the volume meter cube. So flux density unit is per second, just per second. There is no dimension. Means it is calculated at a particular point, but whatever it is. If I have a point, at this point I know the divergence. How much is the liquid, electromagnetic liquid or electrical liquid or magnetic liquid is gushing out of this point. Make a closed surface around it and see from the closed surface how much is the liquid gushing out of the surface. Divide it by the volume of this closed surface. It will give the density. It will typically give the flux density. Okay, that is the scenario. It will typically give the flux density. The net flux coming out of the volume, divide it by the volume. Or if someone knows the flux density, multiply it by the volume or multiply it by the dV. If it is algebra, if flux density is numerical, like minus xi plus yj plus zk, what is the flux density for this velocity vector? Then flux density can be calculated. Take a point at which I want to calculate the flux density or divergence. Around it, make a closed surface and divide it by the volume. That way also someone calculate flux density. Or just you have someone has velocity vector, just calculate the divergence df1 by dx plus df2 by dy plus df3 by dz, provided at that point where I am calculating the divergence, velocity vector should be continuous. If velocity vector is r vector divided by r to the power 3 and I am calculating the velocity and divergence at origin, then r to the power 3, that is x square plus y square plus z square to the power 3, 3 by 2 is 0. Undefined. The velocity vector is undefined at the origin. So I cannot calculate divergence at that point with formula df1 by dx plus df2 by dy plus df3 by dz. Through this formula, I cannot calculate the divergence. For that, for that, if I have the origin, make an arbitrary sphere around it. Calculate the flux, divide it by the volume. That will give the flux density or divergence, not this formula. But if it is continuous at that particular point, then we can go with this formula. And velocity vector is minus xi plus yj plus zk. This is well and well continuous at origin. So net flux will be 1 minus 1 plus 1 plus 1, 1. If flux density that calculated through divergence formula, if flux density is constant and then I want flux around, I calculated the flux density at origin, but if it is constant, it is same where everywhere. If I know the flux density that is constant, not algebra. Algebra means every x and y z it will be different. But if it is constant, then I make any closed surface around it, around any point. Then if I multiply it by the volume, it gives me the net flux around the surface. Okay, that is the formula. Means if I have flux density or divergence around which I take a closed surface, and just multiplied with the volume of the surface, flow surface, it gives the net flux. But if it is algebra, algebra means if I know at any point what is the flux density, like I gave example that velocity vector is x into y into z, and it is continuous at the origin. In that sense, the flux density at any if I'm calculating flux density at point 2 comma 2 comma 2, there also it is continuous. There the flux density will be x into z, sorry, y into z plus x into z plus x into y. This is algebra. If I want to calculate flux at point 2 comma 2 comma 2, if I make a sphere around it of radius r and flux around it, if I know the flux density, that is x, that is y into z plus x into z plus x into y, because of the vector velocity vector that was, I'm sorry, for the kind of I'm really sorry. Okay, consider the velocity vector. What velocity vector? The velocity vector is x. Velocity vector is x into y, x into y. I'm sorry. The divergence is df1 by dx. df1. Okay. So velocity vector is x into y into z. x, y, z, I plus xyzj plus xyzk. This is velocity vector. Divergence at point 2 comma 2 comma 2. If I want to calculate, first I see if this velocity vector is continuous at 2 comma 2 comma 2. It is continuous. It is not infinite, undefined. Df1 by dx plus df2 by dy plus df3 by dz will give the net divergence at point 2 comma 2 comma 2. What is df1 by dx plus df2 by dy plus df3 by dz? If I want to calculate this, then it will be y into z plus x into z plus x into y. This is the net divergence. It is not a vector, it is pure algebra. Now set the value of x, y, z at 2, 2, 2. That is the divergence at that point. But if I want to calculate a flux of a closed surface, consider a sphere that is centered at point 2 comma 2 comma 2, what would be the flux? In that sense, flux density is algebra. I cannot multiply with the volume of the flux out of the way. Then what we need is the flux density into d of volume. D of volume means dx, dy, dz. This will fall into integral calculus because multiplication, that is flux density into volume, is not straightforward. Flux density is variable with x, y, z. The density is dependent upon x, y, z, where x, y, z are independent. If, if dependent and independent algebra is coming into the picture, then multiplication of algebra will fall into integral calculus. This is primitive calculus. So, so, so density dot d of volume will be net flux that will be calculated. Anyway, now we were tackling a question. If I know flux density, if I know flux density, or if I know divergence is zero, consider there is a velocity vector for which at any point flux density is zero, divergence is zero. Can someone prove by the basic flux calculation, that is velocity vector dot product with the area vector is also zero? Anyone would say that if divergence of a velocity vector is zero, then net flux coming out of the surface around divergence is calculated at a particular point. If I know a particular point, at that point flux density or divergence is zero. If I create a surface around it, then how much is the flux coming out of it? Divergence dot product with the dV. If divergence is zero, the net flux coming out will be zero. Now question arises, if I know divergence is zero, can someone prove that divergence of vector field capital F is zero? I know flux density is zero. Can someone prove with the first principle, that is velocity vector dot product with the area vector in a closed loop is zero? Certainly, because someone would say, then calculate with the flux density into volume. That is zero. No, calculate with the velocity vector dot product with the area vector. That is basic calculation of flux. Velocity vector dot product with the area vector will be zero for a closed loop if divergence of the velocity vector is zero. Anyway, We will try with one example. We started. Consider consider there is a sphere that is centered at the origin. There is a sphere that is centered at the origin. Now, at the origin, divergence of a velocity vector is zero. And then let's calculate that the net flux coming out of this closed surface, that is sphere, around the origin, and that is zero. If divergence is zero, then there are two ways to prove it is zero. One is that velocity vector or vector field is constant vector. If it is a constant vector, then df1 by dx plus df2 by dy plus df3 by dz all will be 0, 0, 0, like ai plus bj plus cj. AI plus Bj plus Ck, where A, B, C are numeric. If this is the velocity vector, AI plus Bj plus Ck, if this is the velocity vector, then all derivation will be 0. In that sense, divergence is 0. Or df1 by dx plus df2 by dy plus df3 by dz, all addition is 0. That is also possible, like minus xi plus y by 2j plus z by 2k. That is also 0. So any point which is behaving like a router, whatever that velocity is coming in, same velocity is getting distributed in other direction. Then also the flux density or divergence is 0. Or the velocity vector is a constant vector. It is always in one direction. It is not changing. If I say minus xi plus y by 2j plus z by 2k, at every x and y, the vector will be different. That is algebraic vector or variable vector. If it is a variable vector, net df1 by dx plus df2 by dy plus df3 by dz is 0. Then also divergence is 0, or it is a constant vector. If I say my vector field divergence is 0, I consider this is a constant vector because that also fulfills the dream. In that sense, I am trying to calculate flux out of a sphere, flux out of a sphere that is centered at the origin, where velocity vector is ai plus bj plus zk. It is a constant vector, numeric vector, because I know divergence is 0. Someone would say, no, 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 it is not a, it is, you are thinking it is a static vector. No, no, it is a algebraic vector, whatever it is. Net result is same, divergence 0. Let me take a algebraic vector, a constant vector, ai plus bj plus zk, or I plus j plus k. Who stops me? Okay, ai plus bj plus zk, dot product with the area vector. Area vector, that is we have calculated, that is area vector can be written as d of position, area position vector, that is dp by dxy plane, dp by dxy plane into dxy plane, that is dp by dx cross dp by dy dxy plane. That will come as I plus dz by dxk cross product j plus dz by dyk. Net is minus dz by dxi minus dz by dyj plus k dx dy, dot product with the ai plus bj plus zk. In a closed loop, this integration will be 0. That is required because divergence is 0, and for divergence is 0 for a velocity vector, we have taken velocity vector as a constant vector. Okay, that is the idea. Anyway, now if the flux calculation is velocity vector dot product with the area vector I am taking d of differentiation, d of area position vector, because both are same. Please watch our previous video. Both are same. Then d of position vector is same as d of position vector by d theta phi plane into d theta phi plane, because we are taking calculating flux of a sphere that is centered at the origin. So if I take surface area for the flux calculation, here phi and theta are variable. Where radius is one, constant radius is there. Consider that radius is 1. Radius is 1. In that case, d position vector by d theta phi into d theta phi, dp by d theta cross dp by d phi into d phi, d theta phi plane, dp, position vector is xi plus yj plus zk. That is xi plus yj plus zk. X is a is the radius of the sphere, or r is the radius of sphere that is constant on the full surface. R sine phi cos theta I, spherical coordinates. R sine phi cos theta I plus R sine phi sine theta j plus R cos phi k by d theta cross same by d phi. If someone settle down, it becomes R sine phi minus sine theta I plus R sine phi sine phi cos theta j. Next nothing. Cross product with r cos phi cos theta I plus r cos phi sine theta j plus r sine r minus sine phi k. This cross product someone has to settle down. Then d theta d phi integration is there. We will do it. So r sine phi minus sine theta I. If I make cross product I cross product I cross product 0 with j cross product will come. I cross j is k, minus is there. So, so kth component will be r square sine phi cos phi sine square theta minus will be in front of you minus r square sine phi cos phi sine square theta k. Similarly, the jth component of this, if it cross with I component on next side, then it will result in minus k. Then it will be r square sine phi phi cos square theta k minus minus two k components are coming. If I settle down, then minus I can keep outside minus r sine phi cos theta sine phi cos phi in bracket sine square theta plus cos square theta k, that is gone away. So k component now is minus r square sine phi cos phi. Just keep it. Now we have again I component and that side we have k component. I cross k is minus j. I cross k is minus j. Similarly, I have j component. J cross k is minus I. Sorry, j cross k is I, not minus I. Let's settle down minus j first. Now we have r sine phi minus sine theta. Cross product with r minus sine phi minus minus plus again minus. So minus r square sine square phi minus r square sine square phi sine theta, that is j component. Similarly, minus r square sine square phi cos theta will be ki component. Now if I settle it down, then it becomes minus r square sine square phi cos theta I minus r square sine square phi sine theta j minus r square sine phi cos phi k. Now full I have to do dot product with ai plus bj plus zk d theta d phi. This is the net kind of calculation. Then it will result into a into r square minus a r square. Now minus r square. Let's forget r square. Consider radius is 1. Forget it or keep it outside. Everywhere minus is there, that is also keep outside. Minus r square constant always outside. Now it becomes a sine square phi cos theta I vector dot product gone plus b sine square phi sine theta plus c sine phi cos phi d phi d theta. Let integrate with the phi first. Let integrate with the phi first. If someone integrate with the phi, or someone can try theta. Okay, someone can try theta. If someone tries theta, anyway it becomes zero. Anyway, let not go to the climax. Let's try with the phi first. If someone tries with the phi first, then it will become minus. Sorry, it is sine square phi cos theta. Sine square phi integration is phi by 2 minus sine 2 theta phi by 2, or this I component is first component is sine square phi, second component is sine square phi. I can rewrite it as sine square phi cos theta sine theta in bracket. Sine square phi is common. Integration of sine square phi is phi by 2 minus sine 2 phi by 2. Integration phi is 0 to pi. Full I am taking 0 to pi. Then 0 to pi. In that sense, pi by 2, if I keep pi, then it will be pi by 2. Other is 0, nothing. Sine 2 pi is always 0. Pi or 0 pi 0. pi by 2. Now integration is pi by 2 in braces cos theta plus sin theta. And that side we have now sin phi cos phi. What is integration of sin phi cos phi d phi? If I take sin phi cos phi integration, second term, now it will be sin phi integration of cos phi, that is sin phi, sin square phi, minus differentiation of sin phi, that is cos phi, and integration of sin of cos phi is sin phi. Same sin phi cos phi comes, I can take it this side, it will become integration of 2 sin phi cos phi. Integration of sin phi cos phi will be half sin square phi by 2. Sin square pi by 2 is the net integration. 0 to pi, gone. What came to us is that pi by 2, I can keep it outside now. Outside is anyway r square, outside is minus r square pi by 2. Now we have to do integration of cos theta plus sin theta d theta. Integration of cos theta is sin theta. Integration of sin theta is minus cos theta. From 0 to 2 pi, theta goes from 0 to 2 pi. If I see the cos theta sin theta, now it becomes sin theta minus cos theta. Sin theta 0 to 2 pi completely gone. Minus cos theta, minus keep outside. Cos theta 0 to 2 pi. 2 pi cos theta is 1, 0 is 1, 1 minus 1, 0. So net kind of flux that is calculated around any point for me divergence is 0. If it was divergence is 0, I consider the velocity vector as a constant vector. If it is not a constant vector, if it is algebraic vector, then it will be completely different kind of integration we will get. We will get in theta and phi. If it has any x or y component, whatever we multiplied velocity vector dot product with whatever we had area vector, that will come in more theta and phi, and it will not resolve into 0. So with the constant vector, with the constant velocity vector, for which divergence is 0, at any point if I take a surface, closed surface, then it is 0. Anyway, someone can try, if I have a divergence is 0, I have a constant field, and if I take a cubical region around it, then again divergence will be 0. For constant velocity vector, that is ai plus bj plus zk, if I make a cubicle centered at the origin, that at that which the divergence is 0, again it will be 0. We will try in this in next session, and then we will proceed by how it works, because we gave one example of closed surface of a sphere, then a cubicle, cuboid, but closed surface can be any mold. Okay, how we can go ahead that for any closed surface, if divergence of a velocity field or vector field is 0, the net flux coming out will be 0 with the net calculation, not through the flux density. Okay, so don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.